I was told that what I'm trying to estimate is the true proportion, okay, right? The true P. What is the true proportion of customers that would rate this company with one of the two highest ratings for customer service, okay? Now, we were told that we want to be within 3%, and that the level of confidence we are using is 95%, right? Okay. When we are given something like this, where we're told we want this to be within a certain percent, that means plus that percent or minus that percent. They're giving us the margin of error, okay? So yesterday we talked about this formula, right? We looked at this yesterday, this basic generic model of a confidence interval. We looked at this, yes? Okay. What part of this, statistic plus or minus critical value times standard deviation of the statistic, what part of that is considered to be the margin of error? Andrew? Yeah, it's the plus or minus, what follows, right? Okay, so what follows the plus or minus is the margin of error. So what do we use for critical value? Z star, and then we're talking about estimating a proportion, and so we know the standard deviation for a sample proportion is the square root of PQ over N. But of course we don't know P and Q, so we use what in its place? P hat and Q hat. So our margin of error for a confidence interval for a proportion is found by taking Z star times the square root of P hat Q hat over N. Okay, does that make sense so far? Now the most common mistake I see students make with this is they mix up margin of error with standard error. Okay? The margin of error is all that follows the plus or minus. The standard error is just the appropriate standard deviation formula. Okay? And it's called standard error because we're using a sample value which from one sample to another will be different or can be different. Okay? So, in our case here, we want this margin of error to be 3% or less. So we're going to set it equal to 0.03. Okay? Does that part make sense so far? Any questions about that first? What we want to find is N. So we need to get some more information. We need a Z star. We said the level of confidence we're going to use is 95%. Do you remember Z star for 95%? Yeah. Let me write down, we remember we're going to find our Z stars. We had this in our notes yesterday. We're going to find our Z stars by doing inverse norm of half the area that's not in the interval. So for instance, if we're using a level of confidence equal to 95% like we are here, we would take 1 minus 0.95 to find that 5% is not in the interval. Well, that's split up into two tails, so when you divide 5% by 2, you've got 2.5% in each tail. So if you do inverse norm of 2.5%, it gives you the lower critical value of 1.96. We, of course, know that the upper is the opposite. Okay? Now, there are going to be 4 critical values that you're going to get to where you know by heart, because you use certain levels of confidence all the time. The most common levels of confidence. This is Z star for 95%. Okay? Our running red lights, we use 99%, and our Z star is 2.576. That we found by doing inverse norm of 0.005, because 0.5% is in each tail. Okay? Another very common level of confidence is 90%. What's the percent not in that interval? 10%. So how much in each tail? 5%. So inverse norm of 5% is 1.645. And then the other most common level of confidence is 98%. What percent's not in that interval? 2, and half of that needs to go in each tail, so inverse norm of 1% is 2.326. Okay? Now you can still always find those, again, by doing inverse norm of half of what's not in the interval. But you will get to know where you get to where you know those pretty well. Okay? Here we're using 95%. So continuing on here, my margin of error I want to keep to 0.03 or less. Now I've got a z-star of 1.96. All right. I'm trying to find n. I'm fine trying to find n before I ever go and get the sample. So I don't have a p-hat. Uh-oh. How am I going to figure out what my p-hat's going to be if I haven't taken the sample yet? Well, what we have to think about here is we want to pick a sample size so that regardless of what p-hat we get, that sample size is going to be big enough to keep this margin of error down to 0.03 or less. Tell me, what do you know first about your p-hat and q-hat? What do they always add up to? Okay. What p-hat, q-hat do you think we might want to use here to ensure that regardless of what p-hat I actually get, this margin of error won't be more than 0.03? Any ideas? All right, let's think about this. If p-hat's 0.1, what's q-hat? 0.1 times 0.9 is 0.09. If p-hat's 0.2, what's q-hat? 0.2 times 0.8 is 0.16. If p-hat, they're getting bigger, aren't they? If p-hat's 0.3, q-hat is, what is the product of those? 0.21. Where do you get the biggest product? 0.5 and 0.5, right? And that will ensure that even if you get a proportion in your sample equal to 50%, you've selected a sample size that's going to keep this margin of error down to 0.03 or less. So when you are trying to determine a sample size for a particular margin of error, before you've taken a sample, then you're going to use 0.5 for p-hat. Okay? Does that make sense? What's that, Justin? Always. This is if you haven't yet taken a sample. Okay? We're going to look at one in our Frappy packet in a moment where a sample was taken and we know what our p-hat was, so we can use that. Okay? But otherwise, yes, if you haven't yet taken the sample, you will always use 0.5. Okay? Now, let's see how strong our algebra skills are. How do I solve for n? Nope, I don't. Divide by 1.96 first. You got to get the radical alone. And remember, we never round along the way here in solving for sample size. So when we divide by 1.96, that cancels. Now what do? Now we square both sides. We square this, and when you square a fraction, that's like squaring the number on top and squaring the number on bottom. So what I have now, again, I'm not going to round. I have 0.03 squared over 1.96 squared is equal to 0.5 times 0.5 is 0.25 over n. What can I do now to find n? Cross multiply. If I take this cross product, 1.96 squared times 0.25, it should equal this cross product. 0.03 squared times n. So finally, Caleb Edwards, what are you going to do finally? You got it. I'm going to divide that answer by 0.03 squared. Let's see what we get. Would you help me with that? Now just plug all that in, just like Caleb said. 1.96 squared times 0.25, divide by 0.03 squared, and we get n equal to 1,000 what? 0.1. Is that right? Do you agree? That doesn't sound familiar to me. Did everybody do it? Okay, good. All right, we can't take 1/10 of a person. Which is it? Why?
If you round down, then
Andrew, louder.
if you round down, then the proportions 0.5 and 0.5, 0.0 is going to be slightly larger than 0.5.
Exactly. Did you hear that? I'll repeat it. If not, if you round this down, even though it's nearer 1,067 than 1,068, if you round it down, your margin of error is going to be just a tiny bit bigger than 0.03. And they said they didn't want it any more than 0.03. Sample size always gets rounded up. So you would need to sample 1,068 people in order to ensure that regardless of what sample proportion you get, your margin of error will be 0.03. Justin, you're right, but if the proportion did end up being 50% and you rounded down, you're in trouble. Your margin of error is too big. Okay? So we're going to put our algebra skills to work a little bit on these kinds of questions, right? So do you have any questions about that?